Today, we're going to talk about how multiple cultures can clash in education, how and why this happens, and how to address it. Let's get started. So last time, we talked about different problems in education and the fact that in the past, education usually dealt with one culture. Today, Western education has multiple cultures existing in the same classroom. We discussed that multiculturalism is considered a value that we accept as a positive goal in this country, and that means it's here to stay. However, different cultures can have conflicting customs, expectations, and values, and this can lead to clashes in the classroom. And so what happens more often than not is that the rich literature and history of different cultures are not taught in order to avoid creating trouble. The result of this leads to unresolved conflicts and deprives children of a valuable resource in their education. To compound this problem, some solutions to these cultural issues involve imposing behavior standards that prefer one culture over another without proper explanation. Now, I'm not saying that there should be no preferences for one value over another, but it is often unclear to everyone involved what those values are. That includes not only the parents and the students, but often the teachers as well. So let's take, for example, a strong, clear value. We all agree that there should not be violence in the classroom. This is a common value across many cultures, most cultures, because it is disruptive to the learning process. So it's not hard to get everyone on board with this one. Another strong but less clear value is no bullying in the classroom. Some cases of bullying are clear. A certain student is being picked on because he or she is vulnerable in some way. However, sometimes when two or more strong personalities are involved, it's not always clear whether it's bullying or just a fight. So to illustrate this point, we are going to use in this video today a kind of cultural clash that goes on in the field of physics. And I'll explain why I'm going to use this as a substitute for actual, different cultures like Western culture versus Eastern cultures, that kind of thing. So these two bobbleheads are going to represent our two clashing cultures. This one is Isaac Newton. He represents ancient or classical. He's not really ancient physics. He's classical physics. And he's got an apple in his hand. You see, even so many of our icons have little details to them that help us remember what they're about. His apple is supposed to be that his ideas about gravity. The apple, the story is that the apple fell on his head and suddenly he knew how to write the equations for gravity. Okay. And then here we have Albert Einstein. He's our more modern culture. Here he is. For some reason, he's pointing to a 6. I think it may be a G for gravity. Okay. And it's just upside down, because he turned our ideas about gravity upside down. Maybe that's the reason. I don't know if the people who made this know that. But anyway, he represents more modern notions about physics, and these two cultures often clash, and I'll explain why in this video. Okay, so I have a clip from the TV show The Big Bang Theory that tried to illustrate this clash. Usually by the time a clash in education or in the academic field gets to the TV screen, some of the issues have been resolved, or they have to simplify them down. In this clip, we're going to see a clash between experimental physicists, which usually represent more of the older thinking, Isaac Newton, and the theoretical string theorists, who represent the newer thinking, or Albert Einstein. All right, so let's watch the clip.
So I'm withdrawing my objection to your desire to have a relationship with Leslie.
Thank you.
I will graciously overlook the fact that she is an arrogant, subpar scientist who actually believes loop quantum gravity better unites quantum mechanics with general relativity than does string theory. You kids have fun.
Hang on a second. Loop quantum gravity clearly offers more testable predictions than string theory.
I'm listening. Amuse me.
Okay, well, for one thing, we expect quantized space-time to manifest itself as minute differences in the speed of light for different colors.
Balderdash. Matter clearly consists of tiny strings.
Are you gonna let him talk to me like that?
Okay, well, there's a lot of merit to both theories.
No, there isn't. Only loop quantum gravity calculates the entropy of black holes.
Sheldon, don't make that noise. It's disrespectful.
I should hope so. It was a snort of derision.
You agree with me, right? Loop quantum gravity is the future of physics.
Sorry, Leslie. I guess I prefer my space stringy, not loopy.
Well, I'm glad I found out the truth about you before this went any further.
Truth? What truth? We're talking about untested hypotheses. It's no big deal.
Oh, it isn't really? Tell me, Leonard, how will we raise the children?
I guess we wait until they're old enough and let them choose their own theory.
We can't let them choose, Leonard. They're children.
So that clip is very funny because it's entirely relatable. This conflict is essentially over a debate that has gone on for centuries. It's really much older than the conflict between Isaac Newton and Albert Einstein. And we will get into that conflict later on because it's a very important philosophical debate. But this particular debate in the TV show is this: does mathematics reveal reality as it truly is, or does what we observe about the world limit our interpretation of mathematical equations? Basically, does the math tell us what reality is, or do we have to limit our idealistic views of what the world should be? That's basically the debate. All right. And it seems that that is a trivial debate, not worth breaking an engagement over. But this debate has, in fact, destroyed friendships, careers, and even lives. And so while physics is hardly free of conflict, people in physics believe they have one thing in common, and that's to seek the truth. And that is why these debates get so heated. Each side thinks they're the keepers of the truth of our reality, our physical reality. Because of this common goal, we tend to think physics in our culture, and in fact all science, as apolitical. But scientific debates have been known to rise to the same level as serious religious conflicts. And if humans are willing to go to blows for a field of study that should be, let's say, largely devoid of emotion, we can see how it can escalate quickly over any topic at all. If you're not familiar with the politics of physics, the scene in the clip we just saw may not make much sense. Leslie seems out of line to call off the engagement over such a trivial matter. What's missing is the fact that she is in the minority as an experimental scientist. The theoretical physicists completely dominated the academic departments in the recent past, quite much for much of the 20th century. This is changing, but TV shows, as I said before, are often behind the times in their portrayals of real-life conflicts. Also, notice how Leonard takes sides while trying to say that he isn't. He takes the path of least resistance by saying that the argument is not a big deal. By doing so, he is actually siding with Sheldon, who represents the status quo. This minimizes Leslie's argument and, in fact, her whole career path. And so with that one statement, he loses her respect. That's the reason why she breaks off their relationship. If you watch the show, though, you know that both Leslie and Sheldon are headstrong and exhibit bullying behavior, not an uncommon trait in physicists. But they are adults in a highly competitive environment, and heated debates are not uncommon. In the classroom, however, with children, we want to discourage the "I'm right because I say so," and we want to avoid minimizing the minority opinion. We want to encourage real debate on an equal playing field. By doing so, we allow for freedom of expression without potential friendships blowing up. This is the tragedy that we really want to avoid. I call this the purity problem. So there are many aspects to the purity problem. We're only dealing with one of them today. This, just for example, is another one. In science, especially physicists and mathematicians tend to think of other fields of science as just applied physics or math. This leads to this is part of the mechanistic view. When I was in college, I actually had an argument with a friend of mine who was majoring in both chemistry and physics along this line, and I won the argument, and that that chemistry was just an applied physics, and she agreed with me. But even as I said it, I realized it was a ridiculous argument, but I didn't know why. I didn't have enough philosophy behind me to understand what I was actually saying. It's a ridiculous argument. Each one of these fields of study are about completely different things and deal with different aspects of reality. But this is the way we thought and continue to think. This comic came out about 30 years after I finished college, 20, 30 years, I'm not quite sure. But the purity problem itself is basically you have a tunnel vision of reality, and you cannot see things outside of it because it doesn't fit into your reality map that you have in your head. So this is what we really want to do. Are we arguing over something that's important, or are we arguing over a set of opinions that are not important? All right. So to see how these arguments, these scientific arguments that I've shown relate to the wider cultural arguments, we're going to go back to Memoria for a moment to look at the three types of government and the cultures that they represent. Professor is over by the museum, and we have the three items that represent our three main types of governments. These types of governments also represent particular cultures, where one value is one of three values is the forefront of the culture. Okay, for example, the tribal culture, which we have with this ancient stone head. Tribal culture values group honor over the individual. Examples of this are tribal cultures, baseball teams, political parties, and cults. Now, political parties and cults can have deeper values that separate people, and same thing with tribal cultures, but they exhibit a behavior like baseball teams. People attach themselves to a baseball team, one side or the other. Part of you dismisses bad behavior of your own team over an opposing team. This is a natural human thing. You belong to a group of baseball fans, for example, and you want your team to win, and so you're ready to dismiss poor playing or bad behavior because you're attached to that particular baseball team. You have friends who are attached to that baseball team. And so even if you might agree that someone did something very wrong on your side, you might keep quiet about it because you just don't want to lose your friends. All right, you don't want to down talk your own team. So that's what that's about. It can get very serious, though. The pros to this type of culture is group cohesion. The cons are loss of membership if individuals don't agree. This can happen. There are, in many tribal cultures, strong fears of homelessness or loss of family and friends. And we have certainly seen that in the political climate in this country at this time. It can come to some serious relationship problems. All right, so even though we are a democracy, which is represented by the Statue of Liberty, we exhibit a tribal behavior at this time. Okay, so the next one is authoritarian. This is represented by the sword and the stone. It's not actually in the stone, it's behind the stone, but it looks like it's in the stone from this angle. All right, so this represents kingdoms, totalitarian regimes, oligarchies, local strongmen. We see this played out in Wild West stories where there wasn't a lot of local authority and people had to work things out themselves. And sometimes a strong man or a villain would come into a town and upend everything, and the hero would come riding in and eventually take the villain out. Okay, in a civilized culture, we tend to discourage vigilantism, but in places where there is no authority, we hope for someone to come in and rescue us from the local strongman. And so within today, we see this type of behavior with gangs, with very wealthy people in small towns, cartels, piracy on the seas. Okay, so the pros to an authoritarian government are, again, group cohesion, as long as you don't disagree with the rulers or the king. Strongman. Cons are jail, exile, or death if you don't agree with the rulers. Of course, not all authoritarian governments are evil. Some of them are benign, but they can easily turn into malignant governments. Okay. The third type of government is democracy, and that's represented by ancient Athens. But the failure there was it devolved into mob rule, which is why Socrates ends up dying. Then another example is Rome. Its problem was overextension and the growth of its bureaucracy, so that it eventually collapsed. And of course, our culture, many Western countries today are democracies of one type or another. The pros for a democracy is that it's built on individual autonomy and expression. So individual freedom is the pro there. The cons, though, are the loss of group cohesion. It values universal thinking, but by doing so, it tends to ignore truly fundamental differences in values between cultures until they come to a boiling point. And so this is the yin and yang of our Western world. We are, on one side, trying to balance individual freedoms with group cohesion. Okay. So in a multicultural society, we want to find ways of bolstering group cohesion without loss of our life, our liberty, or our community. And again, we may think that this is a new problem, but it's really not. The Jews had both religious and family ties. They were tribes of families. Gentiles, those people outside the Jewish faith, wanting to become Jewish, had to go through a rigorous process to belong to the tribe. We tend to forget that we live in a culture that allows upward mobility and rewards individual merit, whereas in the past, the class structure was far more rigid, and issues involving property and inheritance were a serious concern to individuals. There was no safety net, for example, no social services. So family wealth was serious matter. I've always thought, and it's not an original thought, that the miracle of Jesus was that his teaching gave permission to Gentiles to adapt much of the Jewish religion to their own cultures without requiring tribal membership. The result was that many nations and cultures were united under one religion. So however you feel about religion or Christianity in general, or how Christianity fractured in the Reformation, Christianity was and still is a multicultural success story. Even though cultures and governments are built around one of these three types, tribal, authoritarian, or democratic, we see that all cultures are a mixture of these three types. To see how this is all connected and how all three types of culture are present even in democracy, let's return to the very real situation of the physics debate that we started with, experimental versus theoretical physics. When I was in college, the first 2 years of physics were dominated by what's called classical physics. That's represented by Isaac Newton here. These are the laws of physics that began with Isaac Newton up to the time of Einstein. Then in the third year of college, we began to study relativity and quantum mechanics, which is represented by Einstein here. And a strange thing happens in that third year. For 2 years, reality, what's observed in the universe governs our mathematical equations and systems. If the equations don't fit what is observed in the universe, then it's time to fix the equations. But starting with relativity, all that goes out the window. Now experimental physics is almost non-existent. Well, I know people are going to say there are plenty of experiments, and there were, but you're not doing them as an undergraduate student. You are learning one system of mathematical expressions after another. I am so serious about that. It is math all the time. 2 years of different types of mathematical analysis. And they are all supposed to relate to each other in some way. And it's not always clear why they do, because you don't even know why you're studying all these different types of math systems. And further, the equations begin to define reality rather than the other way around. And don't bother asking questions about it or even thinking about it. You're very much discouraged to think about it. If you're thinking about what it means, then you're probably not understanding the math, you're not smart enough, you're not creative enough, that kind of thing. There's something wrong with you if you can't deal with the fact that it's hard to understand. It's also where the expressions shut up and calculate comes from. It's a very harsh atmosphere. And really, if you haven't been through it, you don't know how difficult this was. First of all, you have a group of people who are usually at the top of their classes in high school. And now you're being told you're just too stupid to understand what's going on. And partly, I think the professors were trying to shield us a little bit because this had been the atmosphere for so long, and for them as well, that if you didn't get in line, you weren't going to get a position in graduate school or a job. It just wasn't going to happen. And they can't really tell you that because you're too young to understand the kind of politics that go on in graduate school or in academic physics at all. All right, but aside from all of that and the emotional trauma from the gaslighting, there were some valid reasons why this happened in this way. But because of human failings, it just got completely out of hand. And we'll see some of that as we go along, why that's so. But for now, the upshot of all of this was, if you were talented in math, this could be a lot of fun. You could dream up all kinds of things, alternate universes, extended lifetimes, wormholes, black holes, all kinds of things. However, if you were in physics because you were more interested in the foundations of reality, physical reality, then, or you were more philosophically inclined, it was pure torture. Now, to give a more concrete example of what I'm talking about, is that you've probably heard of Schrodinger's cat, his thought experiment about the cat. This is the idea that you have one cat in a box, but according to quantum mechanics, the cat is both dead and alive at the same time. This is called a superimposed state. And if you watch Big Bang Theory, you know this. They do a funny bit about the cat. The way it was taught to us was that the cat was both alive and dead, as I said, until you opened the box. Now, my problem was never that the cat was both dead and alive. I could understand that there's some state that we don't understand on the microscopic level. My problem came with the idea that the cat became dead or alive because you opened the box. That is, the cat lived or died because you looked at it. I am dead serious. And in fact, Schrodinger didn't believe it either. That's why he came up with the cat thought experiment. He thought, surely you don't believe that the cat is both dead and alive until you open the box and look at it. That doesn't make any sense. But that is the way it was taught. You were supposed to believe that the cat was both dead and alive until you physically looked at it. And what does that mean? What does it mean to look at something? Is the cat both dead and alive if I don't look at it? And who needs to look at it? Me? Other people? A machine? There's no telling what that meant. Okay, so anyway, Einstein didn't believe it either. But when he was arguing with Bohr about this, another famous physicist, it was believed at the time, or some time after they had their debate, it was eventually settled that Bohr had won the debate when it hadn't actually been settled. But that's what happens when one group of people within a field begin to dominate over the others. They decided that that is the interpretation that we were to accept. And it has been that way since 1939 till at least when I was in school. And in some ways, it's still taught this way. But it is changing. I will attach a video from a physicist I like to follow. Her name is Sabine Hossenfelder. I think I have that right. If I don't, I'm sorry. I'll put a correction in. And she explains the way it's thought of now. All right. And what the real problem is. All right. The reason why we have a difficulty understanding what's really going on at that level. All right. So it's not a very long video. It's worth watching. And I was very grateful to see this because it helped me understand what the craziness was all about. All right. In any event, Bohr himself was influenced by Eastern religions because we were having this difficulty. Physics seemed stuck because we had gotten down to this level where we were having difficulty observing interactions between very small particles. And this was something that really disturbed physicists at the time because there was this feeling that we should be able to understand everything in the universe. But we weren't ready to accept that we might have human limitations because we're finite individuals in bodies that can't understand everything. But he was influenced by Eastern religions, especially by the idea that one could hold two contradictory thoughts in one's heads. Now, I believe, and this goes back to our understanding of different types of culture, is that he misunderstood what was being said about the contradictory ideas. When you live in a culture that's honor-bound, then you don't have the freedom of individual thought, at least not in public. So you have to find a way of dealing with that. If you hold a belief or opinion that contradicts some dogma of the group, you learn to keep it to yourself. That's a private matter. You don't talk about it in public. You keep that to yourself or to some trusted friends or whatever. Westerners are not used to keeping thoughts to themselves. All right. So they're not familiar with this type of cultural discipline, and so do not understand some of the wisdom texts of the past. And this was part of the problem, as I said, is that you weren't creative enough. This is the way you were looked at if you didn't understand this too, both dead and alive. If you were having trouble with that, it's because you weren't, you didn't have a creative or imaginative mind, not that you thought it was insane. Okay. Anyway. In any event, because of Bohr, it became fashionable to try to hold two contradictory thoughts in your head. It was considered enlightened thinking, and that included interpretations of mathematical expressions. You could read those equations any way you liked, as long as you didn't challenge the equations themselves. This is how that developed, all right? And that's when the theoretical thinkers overcame the experimental doers. So it's really very vicious. I mean, I have read over some of the debates and some of the things said in print from one physicist to another. It's a very hostile environment. So this is what I refer to as tribal culture. The tribe is the physicist. It's like two tribes clashing, but one tribe is dominating the other. Also, there's an authoritarian element in universities. These are the people, department heads, school administrators who are charged with getting funding for the schools. They need grant money for these departments. So they don't want people who are upsetting the apple cart. So the whole group cohesion forces are very strong in academic circles. So if you were able to completely live in a world of imagination, this was all good, and I knew some who could do this. If you were able to keep your objections to the cat problem to yourself and you were good at math, you could still get a career in physics. However, if all this felt like gaslighting to you, and you felt like you were being bullied, you pretty much went off someplace else. Some people went into math. I got into computer science. I had good grades in computer science. I felt more real, and I needed something for me personally. I needed something more stable, but I really felt like I had failed at it, even though I did get my degree in physics. And so the physics field lost many, many people because of this. And it's changing again. As I said, there's much more interest in foundational ideas of physics now. And thank God for that. I'm seeing more and more of that. But this is going to take time. It can't just change overnight because the development of certain ideas of physics has gone on for so long. There's nothing to replace them right now. You're really trying to move a mountain here at this point. It's going to have to start over from scratch, and there are people who are willing to do this now, but it's going to take them a long time. We look at Isaac Newton and we look at Albert Einstein as if they are the single movers of all of our ideas in physics, either the classical or the modern. But there's an army of people behind them. And so it's going to take an army to redevelop many of these ideas. And it's not that the equations that we're using don't work. I mean, they work. But what are they explaining? That's the difficulty right now. So we want more cohesion between what we think about the world, the map that we make of the universe has to make more sense than the system that we're using now. So this isn't to say that theoretical physicists have had it easy. Their ideas can't be too radical either because of the funding needs of government projects and university departments. All right. So you have to kind of modify your goals to fit the needs of the group. And you see this in this cartoon that I have here. When do I get to work on the research that I want to work on? All right. Maybe when you're dead. So let's talk a little bit about those difficulties. So as we've seen, physicists are supposed to be interested in the truth of reality. This is what we believe, but that expectation hits a wall. But given the fact that they can interpret mathematics in imaginative ways, they are also very prime for fantasy. So we're going to introduce a real fantasy into our physics department. Now, let's say we have a group of students becoming physicists, and one of these future physicists believes in mermaids. In this setting, mermaids are considered a crackpot theory. All right. So this could quickly become a problem for this student. Okay, so what happens if you have a crackpot theory? Being labeled a crackpot is the worst thing that can happen to you. People avoid you, funding dries up, you can become a pariah. This can escalate to include the institution itself, the department head or keeper of the canon of knowledge for the school might become concerned. Does the student need to be expelled for such a belief? I mean, do they need to be kicked out of the department? We're talking graduate student level here. All right. Now, you might say mermaids have nothing to do with physics, and that's true. Physics involves non-living things. Mermaids, space aliens, Bigfoot are all biological. All right. But because of this very concern about group conformity, we do not need an actual crackpot in the group. All right. This becomes a very risky thing. Again, if it's off-putting, for example, to the people who are donating to the university. All right. So this could get you into big trouble for having this kind of belief that really has nothing to do with the field of study that you're on. People worry that it's going to infect your thinking. All right. So, but, suppose I am the mentor for this particular student. I've signed him on and I want him to do well. And I don't think it's a big deal. All right. Really not a big deal. All right. So I could be clever about it and create a scientific argument that allows for mermaids. I know that most physicists believe in space aliens. All right, and they have good reason to believe in space aliens. We exist on this planet, so intelligent life can develop on a planet. We have ourselves as proof of this, so it's very possible that there could be aliens on another planet. We could fashion an argument that says mermaids and Bigfoot may exist as aliens on other planets because we don't know what form space aliens would take. However, this physics student is not going to concede to this. This is not good enough for him. He really doesn't care what form space aliens take. He believes there are mermaids on this planet. And further, he says, you can't prove a negative. And as any physicist knows, that has been the heart of the argument on the theoretical side of physics for over a century. There could be a multiverse, even if we've never observed one, because you can't prove a negative. Well, that is a problem. But do they have a point? Is it true that you should continue to go on with your imaginary worlds because your mathematics points to it, even though no one has ever observed it? We could look at another physics problem, one that can be proven now one way or another, but also one that most of humanity got wrong for thousands of years. They had to wait until there was sufficient technological development in order to prove one way or another whether the sun went around the earth or the earth went around the sun. For most of humanity's existence, it was believed that the sun went around the earth. And actually, the Greeks were aware that it was a possibility that the earth went around the sun. But as I said, they lacked the technology to prove it. And they had reasons to believe that this wasn't the case. But they did understand relative motion and retrograde motion. So they did have some idea that at least two of the planets went around the sun. But again, no way to prove one way or another. So in this particular case, the experimental or observational scientists who argued against the heliocentric model, that's the model where the sun is at the center, they were the ones who were wrong. And the theoretical scientists were right to hold on to the belief until technical tools needed to prove their side were developed. In this case, the bullying behavior of the group would be against the theoretical scientists, and we see this in the case of Galileo. Galileo wanted to teach that the earth went around the sun, but he was prohibited from doing so until he could find a valid proof. He did not come up with a valid proof. And so he went to, he was a very headstrong, bullying type of person himself. And so he went to war with the Pope in print. And that's where his troubles were. And if you want to read more about that, that is in Arthur Kessler's book, The Sleepwalkers. It's very well researched, very well worth reading. It will change a lot of your understanding of how scientific progress actually happens. It's more of a stumbling. That's why he calls it the Sleepwalkers, rather than this very linear a straight line thing that we think that it is. That's the idea we get out of textbooks, that science just marches along. It doesn't really. It kind of stumbles along. Okay, so how are we going to resolve this in the classroom? We've talked about two types of situations that are resolvable. There's a third that's not resolvable. But let's start with the first two. The first one is mermaids. These are fantasies, okay, or things that can't be proven. All right, things we want to believe in. I'm assigned. Oh my goodness, over here above me, it says I want to believe. That's from the X-Files TV show, which I really loved until they ruined it. But anyway, we all want to believe in things that we can't prove. We all have things that we believe in that we can't prove. We should learn to tolerate these things. These fall under the category of strong individual beliefs. All right. Strong individual beliefs are opinions, and we shouldn't be bullying other people about them. They do seem sometimes to be contradictory beliefs. Buddhist idea of the afterlife and a Christian's idea of the afterlife are completely different. I don't want to go as far as saying they can't both be right, because we are talking about things that we don't understand. All right. So there may be elements of either and one or the other that more fully explain the afterlife. Not everybody believes in an afterlife. Again, these are all beliefs. So people should not be bullied about what they believe in. And we should allow for opinion. This is a matter of courtesy and discipline that we need to reinstate in our education system. Okay, being opinions, it is not necessary to resolve them. Not necessary. To resolve. Gosh, my writing's terrible. Okay. Now, the second type of problem is when you are dealing with something that's factual. All right. And you are disagreeing over the facts of it. Could be a political debate, could be a scientific debate. This is our Schrodinger's cat problem. It's Schrodinger. I can't spell anything today. It's cat. Okay. This is a factual debate. This means both sides can bring facts to their argument. All right. Now, but what happens in this debate if the school insists on one side over the other? Let's take something also scientific, like evolution. Now, many people don't believe in evolution, but as a school requirement, you are required to know what that field teaches. There's a lot of things we don't understand about evolution. But the point is, there are certain ideas that the school expects you to learn that are what is accepted in that field. So you should be able to give those answers, even if you disagree with them. All right. These are testable answers. Later on, you can get into the science and debate it all out with somebody else. Now, one way of dealing with this is to think about how the Eastern idea of holding contradictory thought is. That is, you have the group idea that is accepted, and then an individual objection to that idea. In the Bible, for example, and this was an idea developed out of Jewish thought, we have Jesus teaching about a political debate. In it, one of his disciples says, "Why do we have to pay a tax for preaching?" All right. And Jesus says to him, do the authorities, do people in charge basically, do they tax their own sons, or do they tax foreigners? And the disciple says they tax foreigners. And so the point that Jesus was trying to make is that they were being taxed wrongly. He was agreeing with the disciple that the tax was wrong. All right, so it's a political debate. However, he tells the disciple to look at the coin. And he says, what do you see on the coin? And the disciple says he sees the head of Caesar. And so this is the very famous line, render unto Caesar what is Caesar's, and unto God what is God's. Okay. So, and this is how he's telling him to resolve is we're going to pay the tax. All right, but we don't have to agree to it. Then it's the same thing here. All right, this is resolvable if the student and his family are willing to give the answers that the school is expecting. And as long as this is not a moral objection, there shouldn't be a problem. This should be resolvable. Okay. All right. Now we come to the third question, and this is the moral question that we can't resolve. All right. So let's give an example. I'm going to give an example of slavery. Suppose the student's family believes that some people should be slaves, or the school believes that some people should be slaves. It could be either side. This is a question of morality. This is a moral question, a very fundamental moral question. This is not resolvable if the feelings about it are strong enough. So slavery. This is a moral objection. And this is not resolvable. I did homeschool, and I did look for alternate schooling. And I looked at a private school that was fundamentalist, and I have no objection to fundamental Christianity. But they were also evangelical, and I was told that if my children went there, they would try to evangelize the children. He was being very honest about it. But although I am now culturally Catholic, I was raised as a Protestant. I understood exactly what he meant and what that meant. All right, they would be under a lot of pressure to disavow their Catholic upbringing that I was trying to give them at that time. So reluctantly, we decided not to send any of the kids to that school. It was a good school, but it was a line that I did not want to cross. And I did not want to put my children under that pressure. All right, so those are the three situations. The fantasy, you can overcome that. All right, belief systems, even if they're not fantasy, they're based on, real religions or whatever. If there's basic religious differences between the students, they should be allowed to express what those beliefs are, and they should have exchange of beliefs, and they shouldn't belittle the other one for what they believe in. It's not necessary to resolve this. Nobody has to be right about this. Maybe one person is right about this, but you'll never know. So it's not a consensus problem. All right. It's not a factual problem. Then we have the Schrodinger's cat problem, which is based on facts. It's a factual debate of some sort, and each side has to bring their facts to the debate. It's resolvable in the sense that one side is going to prevail over the other, but there's room for tolerance of ideas. Again, the child needs to learn the difference between, imaginary things and beliefs. I don't want to give the idea that I think beliefs are imaginary. They're not. They're usually based on the things that we observe in the real world around us. However, they can extend to true fantasy too, which includes mermaids. The Schrodinger cat one is really supposed to deal with things that we deal with every day, and they affect our work. And that's why they become important, to kind of give in to what the consensus is to some degree, while allowing yourself to have objections to what the teaching is. Okay. And then thirdly are the serious debates, and these are moral objections, and they're not always resolvable. You're not always able to live with them. And so those are the three situations in the classroom, and learning to distinguish between the three of them will help resolve as many situations as possible. Okay. Will you make mistakes? Yes, everybody's going to make mistakes. We're human after all. But that doesn't mean that we shouldn't try to address cultural differences head on. With the aid of classical literature, wisdom literature from all cultures that are involved, biographies such as the one that I suggested earlier, The Sleepwalkers by Arthur Koestler. You can see that how many debates have been hashed out in the past, and the different personalities that went into it, and the different types of resolutions that are possible. But if you're unaware about how to do this, and you can't distinguish between these three types of problems, you're going to have a very hard time. They're all going to look the same. They're all going to look like highly moral objections, and they're not all moral objections. And without these tools, I think we're depriving students of valuable wisdom for their future. Okay, so that's that for today. Okay, so this is going to be a brief island update. As you know, if you watch my previous videos, I have 3 islands in Animal Crossing. They are Paradise, Memoria, and Haven. Paradise is my first island. It's called a normal core island. Just normal stuff going on there. Memoria is the main island for the Memory Palace work, and Haven is the place where wild ideas go. Paradise and Haven do have overflow stuff from the Memory Palace from Memoria. Okay. All right, so on Paradise, there's nothing really new going on, but the island being in the northern hemisphere has entered springtime. Haven is in the southern hemisphere, so it's entering fall. And here is Finn on Haven. I'm adding some mermaid stuff to the area where the 3 octopi are. There are no mermaids in Animal Crossing unless you think of Pascal the Walrus as one. So I'm going to use the octopi as substitutes. Just keep giving me a new reaction. Great. I get that. Cephalobut. it's hard to say his name, Cephalobot, is an alien robot, and he is also on Memoria. Because according to whatever science or science fiction theory you like, he can be in two places at once. All right, so in this mermaid area, I'm not really sure how this is going to work, but come visit from time to time as I develop it. I did add a new character. Okay, and this is Gramps. Oh, yes, he's kind of a boomer with attitude. All right, it's kind of hard, and it's hard to make these characters look old, but he has a beard and gray hair, fedora, and he's wearing some kind of metal rock type t-shirt. Anyway, this is his antique store. All right, and he has a cannon here. I like this. Kind of reminds me of the old dude in Mary Poppins who blasted his cannon off a balcony on his house every morning. That's when people could tolerate each other. I don't know if I could tolerate that, but, you know, that's the idea. I think I want to move it over to Memoria because Professor hasn't gotten this. You get this from the pirate Gulliver, the seagull pirate Gulliver. So I may be moving it over there, but I'm going to try to leave this space open so when I get another one, I can put it right here because I really like it here. Yes, okay, enough of that. All right, I have pink bulbs here. I don't know if I want pink bulbs. I might have to change that over. On Haven, you're going to see a lot of weeds. This, no HOA here. I don't pull them up. Okay, so this is an island for odd ideas. That's what I'm using it for, and maybe some particular things about physics, because there's a lot of odd ideas in physics. But also for mermaids. Yeah, this is kind of a libertarian island. Okay, we don't ask a lot of questions on Haven. All right, he's going to store this stuff in his attic for Memoria. This all had to do with the way men and women think. I'll have to look up what video that was. And we put the cute little rabbit next to the raccoon. And the thinker right here. Okay, so they go in storage right now. This is a Memoria room. Okay, and then the basement is where I'm going to keep connecting ideas to Paradise. And until I have stuff to put in there, it's going to be his man cave for now. I may add a third character on this island for some fun work with the Mario tubes. You can transport into the resident houses with them, and there are a lot of fun ideas I picked up from watching other YouTube videos about that. So I'm thinking about it. I'm not really sure yet. On Memoria, being another Northern Hemisphere island, it's just past Mardi Gras. And spring is here too. I'm thinking about bringing the cannon, C-A-N-N-O-N, from Haven here to use as an icon for the word canon, C-A-N-O-N, canon of knowledge that we talked about earlier in this video. If I do, it will be here. So in the last video, I introduced this idea of the rule of three, but I didn't really explain it very well, so I'll like to clarify that right now. The rule of three in homeschooling was this. You might have 3 families and 3 methods Method A would work for family A, but it wouldn't work for family B or family C. And then, or you'd have method B, it would work for family A and B, but not for C. The idea here is to basically not give up and looking for a method, and not to feel like there's something wrong with you because you can't make the ones that everyone is agreeing is just the best thing since sliced bread. Okay, just keep trying. Rule 3 is eventually you will find a method that works for your family or for your child in particular. That's the rule 3. Okay. All right. That's all for now. See you next time.